server in Baidu and then just brought in my car over here, stuck it underneath the table. And it has a GTX 980 that I'm using to actually run the transcription in real time. So what I'm going to do is I'm going to play a couple videos for you and do a live transcription. So as I play the video, you're going to see a result appear streaming from our server of what our system recognized from the video. And then once the video is over, I'm going to take the entire audio clip and send it to a third-party API. So this is a server that actually I don't control. This is just a public speech system on the internet, a really good one. And we're going to compare the results. And then after we do that, we're going to add noise and see how the systems perform in noisy environments. For my first clip, I loaded up Jensen from his keynote on Tuesday. So let's take a look.
This topic of deep learning is probably one of the most exciting things that's happening in the computer industry. Arguably,
there we go. So it's now going to the third party. Okay, great. So if we look at the transcriptions here, both of them do really well. The very end of the clip, got cut off a little bit, so we won't look at that. But just looking at the transcription, both of them did fairly well. So now what I'm going to do is start adding noise, and I'm going to add noise from a restaurant. So this is noise that was recorded from a restaurant. So let's turn it up. Okay, so I'm going to add it just a little bit. Hopefully you can hear there's just a little bit of noise, and let's run it again.
This topic of deep learning is probably one of the most exciting things that's happening in the computer industry. Arguably,
okay, so deep speech did pretty well there. Okay, the party of guys starting to struggle a little bit. Let's turn it up even more. So I'm gonna try to make it really hard here.
This topic of deep learning is probably one of the most exciting things that's happening in the computer industry. Arguably,
great. So deep speech still did pretty well. Yeah, we're starting to see a few more errors. Okay, great. So now I'm going to switch to a different clip here. So what I'm going to do is bring up another video. I'm going to drop it in here. All right. I'm going to turn off the noise. So this is Isaac Asimov, who's one of my very favorite science fiction authors, and one of his contributions to the world of robotics is laws of robotics that describe how artificial intelligence should behave. So I'm going to play him reading or telling us what the first law of robotics is.
The first law is as follows. A robot may not harm a human being or through inaction allow a human being to come to harm.
Great. All right, I'll wait for the third-party results to come in. Turns out this clip was just a little bit too long. Sorry about that, but take my word for it, the third-party API does really well on this clip without any noise. Okay, so now I'm going to turn up the noise again. Let's see what happens.
The first law is as follows. A robot may not harm a human being or through inaction allow a human being to come to harm.
Great. So there we have it. I'd like to point out that the times that we really need speech recognition to work the most, when I really need speech to help me out, are times when we're in noisy environments. So I'm really excited about the work that we're doing to make these large neural networks and train them on large systems using many GPUs to really improve the ways that we can use speech recognition. Thanks. That's it.